Hello, everybody. In this guided practice, we're going to do the chapter number 3. I will ask you to please download not only the guided practice file, but also the data CSV file so we can mount it and use it in our collab at the moment, or save it in the same folder if you are using your own computer for this particular element. So we're going to keep it simple. I'm not trying to go as detailed as possible, just to grasp the concept and understand a little bit how pandas will work and what part will help us better than NumPy does. And that will be the previous idea. So the first thing that we need to do, we need to import pandas. So let's do import pandas as PD. And it's asking us to create a series. So let's do series equal. Oops, I'm doing what I'm not supposed to. It should be here. So import. No, we already import, sorry. Series equal PD dot series, and we can do 1, 2, 3, 4, 5. Actually, it's asking just to 4. And we can print our series to see how it looks like. And we can see now in the printing, give us a really interesting results here. Not only provide us the data, 1 to 4, it provides us the label, that is the index by default. And you can see like at the table is type, and we can also see the type of element that we're sending here. It's actually integer, 64 bits integers. So it's a really interesting way to see how pandas start giving more context or more information to, or actually information that we need through here. Now, the next thing that we need to do is do pretty much the same, but it's asking us to give it custom indexes. And to do the custom index, we need to use the index property, as you remember. So let's copy this to rewrite our series. But after we actually finish, and let's do 5 because it's actually doing 5 now. Let's do a comma at the end, and we can just do a simple index. And for the index, we can just relevant to specify what will be the index in the particular element, and the index will be the following. So we need to index equal, and with another one, and let's do A, B, C, D, E. If we print the series one more time, we can see now, instead of having those values 0 to 5 to 4, we just have A, B, C, D, E, and that the data type is actually the same in this particular part. So we can see the difference between without defining an index and define a specific index to our values. So we can look for a specific position. So let's do print series dot ilog 2, and actually should be like this. And we can see that's the number 3 because that's the index. But we can also do but a label here. So let's do print series D. We can do D directly. Oops. And D is a label. It's give you 4. Or we can use also dot loc, and it print the same one over here. And we can see the D is actually for the way that we are working in our environment. We can print what we mentioned before. So let's do print, let's do series dot loc. See, and this should be a square bracket. I'm so sorry for that. Let me put my square brackets there. and it's printing C. Well, let's do something different here. Let's change this E to another C. And let's execute. We can see that C has two different labels, values with the different levels. And when we execute this, all repetitive C's are just being printed because we define the same label. So you can see the label not only is particular for the row, it could be like a category or for a grouping scenario. You can have label for any type of reason that you want. There will be a way to handle those through that particular repetition, the way that we saw it right now. So let's do the next one. So it's asking us if with slicing how that will work. Let's do a simple print series to colon and just with a simple series. There you go. We can see the slicing also there without taking from the second element or the second index all the way to the value that we're pointing through here. It's asking us to import Panda and NumPy. We already did Panda, but let's just do it. Import pandas as PD. Import NumPy as MP. Execute to have those in our environment. And after we have those, we can work with the next element. So we can create a data frame with random data. So we use np random, run dn, to generate 10 by 4 array with random numbers. And then we pd data frame to create a Panda data frame for this array with the names A, B, C, and D. And they will just print the data frame on the screen. So let's do all in one line, well, except with the printing. Let's do our data frame will be a Panda data frame. And my data frame will be from np.random dot run end. Let's do 10 by 4. And then we do comma and we do columns. It's going to be a list of A, B, C, D. Right? And for this, we can just print our data frame to see what we're doing here. And this is actually really cool. You can see I'm random numbers, generating 10 of them from 0 to 9 in 4 different columns, and assigning each column A, B, C, D. So we create a list from a string. That's where it goes separated, and we have like that. That see the how powerful Pandas is for data processing that we need. This will look more likely uh, Excel spreadsheet, almost there, where we can have the different elements the way that we need it. Now, because we saw that, we need now to read, or it says chapter 2, but it's in reality chapter 3. And data frame, let me see if I can change this here. Change chapter 3. Well, so you will see as a chapter 3 after this. So our chapter 3 data file to be loaded, and then we need to import that one. Let me change this one more time. Chapter 3. Well, into pandas. For that, we need to, and this just exclusively for Google Colab. One thing that we need to do, because we have that in our, we have right here, in our Google Drive. The only thing that we need to do, we need to mount our Google Drive in Colab in order to make it work in our file. So the first thing that we need to do is from Google, and it's just here, dot collab import drive. And then we can do drive dot mount, and we'll mount this in, let's do content drive. We execute this, will ask us if we want to have access. Let's say yes, connect. If we give permissions, we continue with the permissions. And I say, well, what type of permission can do is really pretty much like looking at everything that we have. So let's just select all of them. We're just mounting as a hard drive, let's say like that. And we'll have our mount file right here in our element. When it run, we should be able to see it through here. We open this. Actually, it should be this one. We can see now we have the drive on the left side. We open drive, we see my drive. I go and find my folder, and then I found my chapter CSV file. I can just do a simple copy path to select this particular file and start using it in my Google Colab. And that's the way that I need to be doing it in order to provide a way to read it to self. So now that I have the path through here, let's do one more time and copy path. I can minimize this. I will, because this is already executed, I will comment this out because I don't need to remount it. That's really, really important. I already mounted. So the only things that I can do is, well, now I can use pandas to actually start doing something with my file. So let's do, my data frame will be from pandas. I want you to read everything that I have here. As you can see, it goes to my content drive and to one particular file. And if I just print my data frame, and I need to print it, of course, I have an issue right here. Oh, yeah, sorry. So it's not read, it's read underscore CSV. That's the function that we need to have. If I read that and I print it, you can see that now I'm seeing the content of my CSV file. If we go back to here, if I try to just open this, you can see that the CSV start with .18, it finish with minus .03 something, and it just have NaN values, ABCD. I can see that those exactly the one that I have right here. So I'm able to read my data and my seed file here in my Google Colab application. So now what we're going to be doing is we are going to set in that range as index for this data, pandas data frame that we have. We're going to use the that range function from pandas to execute this. So let's do it. Let's do days equal pandas dot date range. We can define one date. Let's do 2025 or 101. And let's do comma period equal 10. It will generate 10 consecutive days starting January 1st of 2025. And I can do assign those to my data frame. So I can do data frame equal data frame dot index actually equal to my days. Oops. And I think they doesn't like it. Oh, it's not defined because I need to have a equal sign, not a minus sign. Sorry for that. And I can do just print my data frame index to see what it does. So I have those, my index is being printed, and I can display my pandas data frame with my data index with a simple print, my data frame. And you can see I have my CSV files, but now instead of having 0 to 9, I have the different dates in consecutive order, the way that we just created through here. And that's a really powerful data manipulation, how to assign a specific value the way that we need it. So the same way that we print the indexes, we can do print my data frame values just to see my values right there. And I can use my print, actually not print, should be my dot describe, just to see a little nice table that tell me the count and the mean, the standard deviation, minimum 25%, 50%, and the max one. Different values that we need to have through there in each one of those particular columns. It's a pretty good way to just describe my data per se. We can mean each column in a data frame. So let's see that. Let's do df dot mean 0. It will mean the mean of each one of those columns. This will be the axis 0 in my data frame df. So I don't need to do the axis 1 because it actually does that. If I do df mean 1, calculate the mean for axis 1 in the data frame. So let's do pretty much the same with 1. And now I do it for my date. And what is the mean per date? So we're able to do a really complex mathematical, well, it's a simple one, but in an easier way in one line. And mean calculation without doing a for loop and go to a process, add it, multiply, divide, everything that need to go to have the mean value. We're able to do it through the rows and through the columns without any issue. And this is one of the powerful part of having this type of element. Now, we know that head show only a few of them. We can do df.head and just printing one of those. It doesn't give me all of them. And I can actually define a specific number that I need. If I need to have a little bigger, by default, just give me 5. And we can see that it provide me that. The same type, if I do tail, just from the last ones. You can see the last one is just January 10. That's the last value, and it starts with 06. So you give me the bottom half of those. Now, if we use df-a, will be a way to get my column A in my data frame. And we can just do this, but I think for this we actually need to print it. Let's try it like this. Or we can just do like that, just to showcase everything that we just selected in our column F. We can select multiple columns with a double square bracket and say which columns do we need to have. And we do that selection and it print with our current index. And we can do a slicing. This will slide from row number 2 and row number 3 with skipping row number 4. And that's the one that we had through here. With index 2. So you skip January 1st, January 2nd, give me 3, 4, and January 5 is going to be the index 4. Remember, index here is always starting with 0. We can access in a specific one. So let's do this. And it's exactly the same as we have it through here. So we do this particular element, it gives you the same behavior as the one that we have through here. So this is a little more like traditional Python elements that we know about it, but we can just define to get for a particular index location to provide those through there. And what is the benefit? That we can do complex math or complex elements through here. It display from 2 and 4, but only from columns 1 to 4. And that's why column A is not showing over here. So we just double slice it, the data the way that we need it. We can do something very similar with this. We have another subset, and here I'm missing a close one. There you go. So I'm printing the same 2 and 3, but only from B and D, because we just have a comma. So we can also select not only a range of columns, we pick and choose what columns do we need, depending the way that we have those through there. But remember, we can use the data range through the index that we added. So here we are in from 6 to 10. That's very similar as the tail. But let's say that we change this to 8. Just give me 8, 9, and 10. So just a way to understand what is being selected across the board. And we can just define with the labels also to select specific columns. So let's do the same. And I just want A to C to skip column D in my selection. So I'm here with the label that I have for my indexes and the label that I have for my columns. And it works. We can use the access rows from January 6 to 10 and preset A and C. This mean is not selecting ABC, it will be just select A and C because we have that particular comma right there. Oh. If we need the full row, we can define just with the index and give the data that we need. Remember, this is a one-dimensional array. That's why it is like this. And here will be the column, will be the row indexes %. But we can define a specific value in a specific column using the add. So here, let's do this. The thing here is that D is not being defined. So let's do a change to provide the D the correct value. So let's import date time. Like from, actually, let's do from datetime. Import datetime. We can do as simple as D equal datetime. And we can program it, have something like 2025, January 6th, 0 hours, 0 minutes, 0 seconds. And now we can just print that particular one and provide me the value that I need. It's a float 64. Let's do as simple as print. Just not to see the type there. And we can see the value. It be printed with a date programmatically through the process. The other thing that we can do, we can filter out and have those selected. As you can see, it's just printing when A, only the one that A is bigger than 0, and when B is bigger than 0. And you can see that nothing there is actually a negative number because we define a specific filter and we tie that filter with the ampersand here for n in the process. The other one that we can do, we can transpose the values. And one of the idea for the transpose will be just to change the order of rows and columns. So we can do as simple as, well, I already know it. Let's do print my data frame. We can do data frame and then we can print or data frame dot transpose. I can see it went from dates and columns to columns and date. And I'm doing both. And I think this actually do it twice. Let's do only one. There you go. And let's do this in order to see it better. Well, in a way, print. It didn't work the way that I expected there. So let's just print the way that it is, and then we just transpose it, and we can see that it's actually printing the other way around as we need it for the moment. We can sort through particular index, and we can do extended false. This what I will be doing is taking from back and forward in the particular date. You see that we now start with January 10 and finish with January 1st. We do the sort index and the axis 0, ascending false. We can do for any column too. And now we can do ascending false. We'll do the name of the column start with D and finish with A. So remember, axis 0 is the label or the index, and axis B will be the columns to we're doing. So we can transpose and change the data the way that we need it. Now, sorting data frames by column values, that's a good one. We can just sort for the values of A. And you can see now it goes to the less number to the bigger number in one particular column. Important doing the axis 0 in order to make it work the way it's supposed to. Now, we can sort it for a column value. So let's sort only January 7 by columns. January 7, we have the columns in ascending order, a way that we can see it through here. We're saying sort the values for only for that one with the axis 1. That means it's through the columns, and that's why we have D, A, B, and C as columns now for the sorting. We can create and display a data frame. So the idea is to call from the dictionary called data, which contains information about names, years, and reports, and data frame index here is by Macallen, Farr, etc. We need to print the data frame function to display the resulting data frame. So let's make this a little more complex. We already have pandas. So let's do simple data equal, and with a dictionary, we select names, and let's have a list here. Let's do Bob, Rosie, oops, let's do Sam. Look like today I don't know how to type. I'm sorry for that. Let's do Gabriel, and let's do Rodolfo right here. Cool. Now let's do cheer, another dictionary key, and let's do 2020, 2021, 2022, 2023, and let's for last 2024, and another key that will be reports, and that will be another list. Let's do 6, 13, 15, 17, 20, right? So we have a dictionary there, and we can do a simple data frame equal panda data frame. And somehow I think I lose my panda. I don't know, it didn't came up. So let's do import pandas as PD. Cool. And let's do for my data. And my index will be equal. And let's define a couple of cities there. Let's do McAllen, Far, Done, Westlaco, and let's do McAllen one more time. and we do our data frame to be printed. We can see right there, Bob, Rosie, Sam, Gabriel, Rodolfo, for different years and the different reports. The index being created by cities. So a pretty cool way to create a data frame from a specific dictionary that Python could provide to us with the traditional convention. So let's add another column to a data frame. Let's do import numpy as np and do schools equal np.array. And let's do stc utrgb utsa. Let's do Texas A&M, or let's do simple A&M. Let's do, I don't know, MIT probably, right? And we can do data frame. Oops. So we create the data frame, the school, the column school, and we assign it to that. And we just print my data frame. And you can see right there that the school's been added to my data frame that we created in the previous step. And now I have an extra column with this naming convention. We can drop in rows to remove row from a data frame. So let's do as simple as data frame drop McAllen and Donna and print it again. And we can see that we didn't drop it. Interesting. Let me check really quick my notes. I always forget that this doesn't return or doesn't affect the original one. So we just return a copy, or we can print it right there. And you can see only we have far and Westlaw code now, because McAllen, Donna, and McAllen got dropped for my data frame using that. So we can filter rows too. Like if the name is not Sam, don't print it. We can see that Sam, it doesn't appear. And we can drop a specific one. Let's do a data frame to see it. And let's do drop one. And we can see now the first one is not there. We drop the one with index number 1. We can draw multiple indexes with this command. And we send the which index 1 and 3. So now we have even less. Now we just have Bob, Sam, and Rodolfo out there. We can columns be removed too. And let's just print this. And we can see that it doesn't show the reports columns anymore. I need to mention what axis belongs to. Remember that part. We can draw by ID, and it's the same as the previous one. We define the columns and number the columns. That actually works. And we can use also multiple columns with commas. And that actually works too. So just a way that different commands and different way to use them to manage the data, to work on through the data here and there. We didn't saw, like, for example, removing nulls or not the numbers and things like that, but you can see it with the query and the filtering. You will able to find those really easy through the process. So here we just need you to upload the PDF file, and that will be it. Meanwhile, I hope that you like it. Remember, as always, any question, any doubt, don't hesitate to reach me. Happy coding, everybody.